Welcome to qnawire.
Hi, so for this question 13, I already answered in the previous question, so we're going to focus on question 14. We have a solid cube of benzene, C6H6, which has a mass equal to 10 grams and is placed in 10 grams of water at 30 degrees Celsius. The cube of benzene is at a temperature equal to the melting point. So that means that we're not going to require any energy to increase the temperature of the benzene cube. But the information that is given to us is that the delta H of fusion of benzene, the heat of fusion, corresponds to 9.92 kilojoules per mole. And we're asked what is going to be the temperature of the water by the time all of the benzene has melted. So the way that we can think about this result is by thinking that the heat that is given by the water will be equal to minus the heat absorbed by benzene. So the heat from water is equal to mc delta T with a minus in front of it. And this is going to be equal to the heat required for melting all of the benzene. In this case, it will be N amount of mole of C6H6 multiplied by the delta H of fusion. So we can proceed and do the substitutions. First of all, if we know that the mass of benzene is equal to 10 grams, then the amount of mole will be equal to 10 grams divided by the molar mass. This is 10 grams divided by 78.11 grams per mole. The amount of mole of benzene is 0.128 moles. So now we can proceed with substituting the values over here. The mass of water is 10 grams. The specific heat of water is equal to 4.18 joules per gram degree Celsius. Delta T for water, it is going to be equal to final temperature minus my initial temperature. My initial temperature for water is equal to 30 degrees Celsius. And on the right hand side, we're going to have 0.128 mole multiplied by the delta H of fusion. In this case, it's given to us in kilojoules, so we can convert it to joules simply by multiplying by 1000. So we are going to have 9,920 joules per mole. As you can see, grams are going to cancel out. Degrees Celsius will cancel out with the degrees Celsius over here, and moles with moles are going to cancel out. So what we need to solve for is for the final temperature. In this case, this becomes minus 41.8 final temperature. Minus with minus becomes a plus. 1254 joules. And this will be equal to 1269.76 joules on the right hand side. So we need to solve for final temperature. My final temperature will be, this would be 15.76 over minus 41.8. And the result will be minus 0.377 degrees Celsius. So now Can we have water at minus 0.377 degrees Celsius? No, we cannot. So what is going to happen is that my final temperature will be equal to 0 degrees Celsius, and a portion of the water freezes. Now, how do we know what portion of the water is going to freeze? Well, let's calculate the amount of heat required to decrease 0.377 degrees Celsius. So, to have this change of temperature, we're going to require, for the 10 grams of water, this would produce 15.76 joules. So, this corresponds to energy absorbed from freezing. We know that the heat of fusion of water corresponds to 6.01 kilojoules per mole. So let's see to how much this energy corresponds. 15.76 joules divided by 6,010 joules per mole, and multiply it by 18 grams in 1 mole. So this corresponds to an amount of 0.047 472 grams of water that will freeze. And at the end, we're going to have a mixture of, at 0 degrees Celsius, of water and a very small amount of ice. And with that, the problem is solved. Now, if you want to know how much of the water remains, simply you can subtract 10 grams minus the value that we just found. You're going to have that we get 9.9528 grams. So when all of the benzene melts, we will have a mixture of 9.9528 grams water plus 0.0472 grams of ice plus my 10 grams of benzene as a liquid. And all of this is going to be exactly at 0 degrees Celsius. And that would be all. Thank you very much and have a good one.